Hello and welcome to Data Analysis and Visualization with Python course. This is the fifth video in the series, and in this video we are going to take a look at the second module of this course, which is the Python Pandas library. So let's get started. Pandas is a library for data manipulation and analysis, just like NumPy, but offers data structures and operations like manipulating tables and series to solve real-world data manipulating issues. It is free and open source. It is built on top of NumPy library, which provides base tools for manipulating arrays and perform operations on multidimensional arrays. Much of the data structures in Pandas use the underlying NumPy arrays and perform operations on them, but provide even more functionality. So in the previous videos, we have looked at the NumPy library. We know that NumPy offers tools for multi-dimensional arrays and their functions. And NumPy mostly deals with numerical data and uses unabstracted data, but when performs awesome calculations on them, but without having meaning to the data. I guess in previous videos, we discussed the idea of abstraction. And to understand the arrays better, we perceive it in the form of rows and columns. But in reality, it's only a list consisting of lists and elements. And so let's take a look at how Pandas is different and what additional features does it offer. So mainly Pandas works with tabular data with tags and headers and two-dimensional arrays to solve real-world problems. So right off the bat, we know that our data has meaning in Pandas, that the rows and columns mean something. Unlike the manipulating NumPy arrays where data could be anything, we just know about performing operations on them. Furthermore, Pandas offers an in-memory 2D table object called the data frame. We will study this in the future videos. Pandas library has better performance with extremely huge tabular data compatibility. It provides series data structure that makes data cleaning extremely easy but is slow as compared to NumPy arrays. Well, you have to lose something to get something, and when I'm going to explain about the series data type, you will realize why it's an amazing data structure. However, it is slightly slow as compared to the NumPy arrays. Pandas is practical and offers easy import, export, and management of data. So importing and reading from large CSV files and spreadsheets is easy. So let's take a look at the Pandas library. And firstly, we are going to be taking a look at the series data structure. Okay, so first of all, let's just import the Pandas library by typing in import pandas as pd and run that to make sure everything is working correctly. Alright, so the series is one of the most important data structures in Pandas. We can say it is a mixture between a list and a dictionary. The items are all stored in an order and there's labels with which you can retrieve them. An easy way to visualize this is in the form of two columns of data. One of the easiest ways to create a series is to use an array-like object like a list. So here I will make a list of 4 people. Ali, Martha, John, and Saad. Now we call the series function in Pandas and pass in the people. So pd dot series, the s is capital, and we're going to pass the list of people. And if we run this, we can see the series data structure is displayed on the screen. So series is a top level function and it takes the list as parameter, and that's how you create a basic series object. We can see the output is a series object displays onto the screen. We see here that the Pandas has automatically identified the type of data in the series as object. This is because we have used strings in the list. And those numbers, although represent the index of each element, in the series object they act somewhat similar to a dictionary keys, these elements. And so we have multiple data types in the series object, which is why the Pandas identifies the type as object. We see that the values are indexed with integers starting from 0 up to 3. If instead of using the strings, if we give a list of numbers, we will see that the D type in pandas is going to be int 64. So numbers equals a list of numbers, they can be anything, and pd dot series numbers. If I run this, we can see that the D type, the data type is int 64. There are several details that we must discuss about the data types, and one of them is about handling of null data by both the libraries pandas and numpy. So in case we want a typed list, which means that the data type of the list is predefined and we have an absence of data in the list as well, the first thing we can do is check what data type is the pandas series if there is a none value in the list. So I'm going to create a list of people like we did before, but this time I will leave an element as none. So Ellie, Martha, John, Saad, and none. This element is going to be none. And now if I pass it into the series function, pd dot series people, and if I run this now, we can see that the D type is an object. But if I create a list of numbers and then include a non-value inside that list, see what happens. So above we made a list of strings. Now I'm gonna make a list of numbers. Numbers equals 1, 2, 3, 4, and the last value will be none this time. And pass it to the series function. And if I run this, we can see that the D type is first of all float 64. And then if you notice that the value nan is different from none. Okay, so let's clear some things a little bit. First of all, the reason why D type of this series is float and not int or object is that pandas treats nan as a float point value, and because of that pandas converts all the integers to floating point numbers. It is important to know that the nan value comes from numpy library, and numpy has syntax as follows to generate a nan value, and pandas of course is based on top of numpy. Secondly, pandas library indicate the absence of number as a floating point value, which is known as not a number, or nan for short. And since nan is a float point value, it converts entire data type for the series to float. Thirdly, it is an important thing to know that nan is not equal to none. So for example, if I import numpy as np first, and then I'm gonna do np.nan, which gives us the nan value, and compare it to none. And if I run this, the result is going to be false. Interestingly, even if we compare nan to itself, the result is false too. So np.nan equals np.nan, even though it should be true, it returns false. And for this purpose, we must use special functions to make that work. So numpy has a function np.isNan, and in there we enter the nan value, and this should now return true. It is important to notice that nan is similar to none, but we have to remember that nan is a numerical value which is treated differently for the reasons of efficiency that are beyond the scope of this course. So we are not going to discuss that in detail. And now we are going to take a look at some of the more ways series can be generated in Pandas library. We just saw how to create series using lists, but what about dictionaries? Can series be made from dictionaries? Well, yes, they can be made using dictionaries, and it's important to know why. Sometimes we might want to create labeled data and then manipulate the data. A series can be created directly from dictionary. The index in the series is then automatically assigned to the keys of dictionary that we will provide. So let's take an example. We make a dictionary of people with names as keys and their countries as values. So here we have a dictionary with the keys of names and their countries as values. So I'm gonna write s equals pd dot series people, and I'm gonna print s. Because of the string data, the d type is set as object, and this time the index is also a list of strings. We can get the index object using the index attribute s.index. So it gives you all the values of the index. Okay, so another fun fact is that the d type equals object is not only applied to strings but also for any arbitrary objects. Let's take an example. So I'm gonna create more people equals list, and this is going to be a list of tuples. So pd dot series more people. So you can see that it was string data, and that's why Pandas set the data type of the series to object, and each tuple is stored in the series object right here. Okay, so lastly, let's create another series. I'm gonna print a dictionary, and I'm gonna make a series f equals pd dot series students, and but this time we can make series object out of specific values of the dictionary. So we can add a parameter here. You can see index equals a list, and in that list we can provide the keys of those dictionary. So Saad and Ali, right? So if I print f, we can see that only these two are here in the series object. But here's a curious thing. If we do exactly what we did above, but add an index that is not in the original dictionary, what happens? So we know above, so I'm gonna write x equals pd dot series. So we are making another series of students. Index equals list Saad Ali, and this time I'm gonna add John as well. Notice that John isn't in the original students dictionary. So if I run this, you can see that all of these indexes are included in the series Sal, Ali, and John, but there is no value of John in the original dictionary, and that's why the only values that we got is from Saad physics right here, Ali chemistry right here, and there was no value for John, so it just returned a not a number object. So in this video we have covered the basic series data structure, and we have learned how to create series from lists and dictionaries as well as tuples, and finally how pandas changes the type of data that has missing values. And so that's it for now, and in the next video we will discuss about how to query a series.